Hello guys, welcome to econometrics. We're going to be looking at the Granger Causality test approach using Eviews. The Granger Causality test was introduced by Granger in 1969, and the Granger Causality test is a statistical hypothesis test to determine if one time series can predict another. Also, the Granger Causality test assesses whether past values of variable x provide statistically significant information about future values of variable y. There are some key aspects to know concerning Granger causality. First of all, when it comes to temporal precedence, Granger causality test whether past values of one variable can predict current values of another variable. And when it comes to predictive power, the Granger causality test evaluates whether including past values of x improves the prediction of y beyond using only past values of y. And in terms of causality, the Granger causality does not imply true causality, but rather predictive causality or temporal precedence. And Granger causality assumes linear relationships. However, it may not capture non-linear relationships between variables. Now, concerning the causality test, there are 5 scenarios that are likely to happen. The first one is if x Granger causes y. What does this mean? Now, if past values of x significantly improves the prediction of y, then x is said to Granger cause y. That is 1. Then 2, when it comes to y Granger causing x, so if past values of y significantly improve the prediction of x, then y is said to Granger cause x. There are cases when there is no Granger causality. What is that? If neither x nor y Granger causes the other, then the variables may be independent or have a more complex relationship. And then what if both of them Granger causes each other? If x Granger causes y and y Granger causes x, then there is a bidirectional causality relationship. And the fifth one is if either x Granger causes y or y Granger causes x, then there is a unidirectional causality relationship. And there are things to note when it comes to Granger causality. First of all, the data must be stationary. It must be stationary at level. If it's not at level, then we will do a first differencing to make it stationary. I think the data must be conjugated too. I must have an appropriate lag length, and we can now determine causality relationship between the variables. And now let's look at the practical aspect of it using Eviews. Now we'll go back to our model, our parsimonious model, and then we'll look at before that, this is parsimonious model, okay? Then we look at the variables, GDP. Let's check the stationarity. Okay, go to our unit root, standard unit root. Then we'll click levels, okay? It's not stationary at levels. Then let's check the first difference. The first difference. Yes, so GDP is stationary at first difference. Okay, let us check the next variable, government revenue. Let's check using the ADF test at level. Okay, government revenue is not stationary at level. Okay, let us go to first difference. Yes, government revenue is stationary at first difference. Now that we've gotten the stationarity of our variables, I think we'll now check the co-integration. Let's see if both of them are co-integrated using the single equation test. The Granger co-integration fixed. Then put here trend. Click OK. Okay. Now our Granger co-integration test shows that GDP and government revenue are co-integrated. Now that we've ascertained that, don't forget we use one lag. So let us go and use the same lag for our Granger causality. Okay, using the same one lag, you go to view, and then we go to Granger causality. We leave the lag to 1, and then we press OK. Yes, this is our result, our Granger causality test result. Now the null hypothesis is that government revenue does not Granger cause GDP, and is what is significant. It shows that what government revenue Granger causes GDP. Now let us look at an expanded view of it. PowerPoint, the result. Yes, so this is the result. So what does this imply? This implies that what? There is a unidirectional causality relationship between government revenue and GDP, moving from revenue to GDP, because the p-value of the F statistics is 0.0018, which is less than 5% level of significance. Hence, the null hypothesis that government revenue does not Granger cause GDP is rejected. In other words, government revenue Granger causes GDP. Hence, we say the past values of government revenue significantly improve the prediction of GDP. So that is all for Granger Causality test. Thank you and subscribe for more.